All right, now, so let's go ahead and execute this part number 2 of this video. Now, do remember that in the previous part, we have configured your HPA and as well as the service over here and deployment over here. Before we start the part 1, I just want to make you understand about one concept. Very simple one. Let's go over here to your HPA. Okay, so HPA is actually having the configuration. The target is 4%. It has increased a little bit, but not like so much. Let's access this pod. I want to show you one more thing. Kube control apply -f. I'm sorry. exec -it pod name, and then you're gonna give bash. Now that you are inside the pod currently, so now I'm in the document root var www.html. So this has a index.php which says like echo okay. So it does a for loop for 0 equal to 1. So likewise, it just goes on a for loop and just printing echo okay, sorry. So now if I want to do a wget on this one, so if you want to wget will fetch the file. So I'm going to use curl, or you can actually use this URL, which is wget -q -o, I think it's a O or 0. Sorry, it's a O, capital O. And then you're going to type http://localhost. Command not found. That's all right. So just ping localhost, or it's like, let's see if you have curl on this one. Yeah, curl is there. Much better. So curl http localhost, you can see that it's returning okay. So this is what we have seen on the file. Now you, instead of this localhost, you can also give one more thing. So what we have given as part of our, as part of our run, which is basically a label which we have set for our service. So you can also give that PHP Apache. So you can see that that also works fine, totally. Now if you just quit this one, and then if you try to do the same curl command over here on your manager one, it will not work because it doesn't know what is PHP Apache, because it's just a communication between all your pods, and they know what is PHP Apache. But what you can do instead of the PHP Apache is that you can give the cluster IP address with its port number, which is 80. You don't have to even mention the port number. And you can see that you're getting an okay result. So this is what we are expecting to increase the load. Now you can see that gradually it's increasing when I do all those stuff, right? So what I'm going to do right now is to execute a for loop right now. So that's gonna, a while loop, sorry. That's going to execute it through by creating an image. So that's a command for it over here. So this is kube control run -i. It's named as load generator -rm. So this image will be removed once you quit this image. And then this is a busybox image, as you can see, and then never restart. And then you're gonna run a command in the shell prompt. And you can see the -c. While sleep is 0.01. So do wget -q -o-. So this is basically how you can use this wget command to fetch this HTML file without downloading it. And then you're closing the loop over here. So what's going to do is that it's going to run this because there's a for loop inside this PHP Apache as well. So it's going to keep on loading this okay again and again until the load increases. And you know what exactly would happen if the load crosses 50%, right? So we're going to see some scaling up. And then that's the first thing we're going to try. And then after that, I'm going to show you scaling down. So let's just enter this. Now you can see that load generator has kicked in. And you can see that it started to write okay. And you will see that the load will slowly generate over here. So it has crossed 50%. And you can see that new Apache instance has been spinned up. Now this is going to be a huge load on the server. So you can see that here it calculates the all together. So whatever, how many of our servers comes together, it calculates on a global scale. So which means that it's still generating load, and you can see that another server is created up, another pod is created to share the load. But then this jumps to 173% over here, and you can see that it has pinned up more number of replicas over here. I can see that the deployment also going up from 1 to 4 right now, because the horizontal pod autoscaler is spinning up more instances right now. The max it can go till 10 instances over here. So now let's just go to the 10 instance and then see what happens. So it is currently at 7 at this moment, and 75% of load is being pulled up. So now all these servers are handling those requests. Now how this load balancing works? The load balancing works because of the basic principle which we have used so far on our service, like the load balancing service. So you can see that currently the load is under 50%. So the number of servers required to get this work done is 7. Okay, so now you can also increase this load by simultaneously logging into the manager node from another system. You can use this one and sudo group, and then you can run export over here, and then run this one more of this. As you can see that here, I'm gonna use another name over here as a load generator -1, so that it doesn't conflict with the existing pod. So let's just create this. Now you can see that I have again entered another series of OKs over here, which means that the load should increase again, because there's just 2 of this URLs are running simultaneously. So this should go beyond 44% for sure, because 7 instance won't be sufficient for it to run both these things. So you can see that it has gone up to 10 instances right now. So as I'm creating a lot of load over here, so the one drawback right now is that it can maximum create 10 instances, and you can see that it has reached the maximum number of replicas that can be reached. Now let's do a control C on both these instances. Now this is going to go on the error state and removed. So the load balancing will not be there anymore because the load generator is removed. Now that the percentage of utilization will fall down dramatically, it will later realize that we don't need so many instances and starts to scale down. Now, this scaling down process may take 5 to 10 minutes because it needs to 100% determine that it doesn't really require any of the extra processing power at this moment. So in the next 5 to 10 minutes, you will see that the server is going down, and it will go back to having only one pod over here. So in the interest of time, I'm going to pause the video, and when it is starting to terminate, I will unpause it and show you to you. Okay, but that happens like really fast. Let me try to capture that for you. But it takes about 5 to 10 minutes for it to do that. So just bear with me. You can see it now that the 2 instances have reduced over here. Now all these will be noted as part of your description for your, you can see that more instances are getting terminated. So as you can see over here, so when I just type describe over here about this PHP Apache instance, and you can see that here it is throwing up an error or exception saying that it's failed to scale because it's not able to identify because of the metric server is not there. So that's the problem, but we fixed it. But then here over here is the metric servers. That's all right. So here is where you kind of have this new resource allocation over here. And this is like a new size, to 8. And then slowly it would reduce it to new size to 1. So you can see that pretty much the current size right now for your autoscaler is 1. And as you can see over here, the deployment size has also changed from 10 to 1 as well, and you have only one pod running. So this is how you can use your horizontal pod autoscaler to scale up and scale down based on the demand on your CPU and memory. There are other options, also advanced options. I'd see if I can make those videos now or later point of time. But I try to give my course, keep that updated with the latest information, what you have in the town. So anyway, Trace, thank you for your time. I'll see you on another interesting video on the next one.